Alright, Math 3, here's the graphing log's final review. So, essentially we're just graphing these functions, okay? Now, there's a few different ways we can do that. The easiest would be to probably use your calculator. And to just type it in, or to even use Desmos, and type it in that way, okay? And then just graph what you've got, okay? The other way would be to make a table. So like with this one, it's exponential, so we pick some points. Okay, and then we plug some numbers in. Okay, so 3 to the 0, anything to the 0 power is 1. 3 to the first is just itself. 3 squared is 9. 3 cubed, we're just basically times them by 3, so 27, 81, and so on. Okay, now if we're going backwards, negative 1, negative 2, and negative 3, okay, 3 to the negative 1 would be like 1 over 3, so 1/3. 3 to the negative 2 is like 1 over 3 squared, so it would be 1/9. So it's kind of that same pattern, 1/27. So you basically just get 1 over a bigger and bigger number, okay, which tells us we've got an asymptote. And typically we do with exponentials, and this asymptote and logarithms is going to be right there, where y equals 0. That's our asymptote, okay? So then we plot those points we had. So 0, 1 is right about there, 1, 3, 2, 9, and then 327 would be up here. And so we basically look like this. Okay? So domain, remember, is all the possible x values. So as we go to the start out here at the left, we start at negative infinity. And even though it's going to shoot up really quick, we're going to keep going to the right, to positive infinity. So our domain, negative infinity to positive infinity. Now our range, okay, we're not going below 0, so we'd start at 0, and then we're going to keep going up to positive infinity, so 0 to positive infinity. Now our end behavior, if you remember, the way we write this is we say, as x approaches, and first we'll talk about going to the right, so as x approaches positive infinity, f of x, where does that go? Well, our function is going up to positive infinity. Okay, so the domain and the range and the end behavior all kind of are connected. So then the other thing we have to remember to write is this left side, as x approaches negative infinity, so as it goes to the left, where is f of x going? And here f of x is approaching that asymptote, so it would be approaching 0. Okay, and that's what it would look like for the exponential. Now for the log, okay, remember the log is simply the inverse. So honestly, we just flip-flop those two and make this our x and this our y, because that's the same idea. So we'd have an asymptote here at x equals 0. Okay, we'd have a point at 1, it's a really small graph, right about there. Then at 3, 1, a little too high. How did I erase both of those? Don't know. So right about, oh my goodness, I can't zoom in. So then we'd go to 9, up to 3, and so forth. So it looks something like this. Okay. Now, if we talk about the domain here, okay, we don't never go past this side, so our domain starts at 0, and as we go to the right, we go to positive infinity, 0 to positive infinity. Okay, our range, as we go down, we start at negative infinity, and we're going to keep going up to positive infinity. So negative infinity to positive infinity. Now our end behavior, as we go left, so as x approaches negative infinity, f of x approaches 0, because we're hitting that asymptote almost. And then as x approaches positive infinity, as we go to the right, this is just going to keep going up to positive infinity. Now what you should notice here is that the base of 3 on both of them, these are exact inverses. Look at the domain and the range, how they switch. The range and the domain. Okay, these how they switch. The asymptotes how they switch. That's That's all we needed to do for those ones. Okay, now let's graph these other two logs. So once again, I would graph this, or knowing that it's just transformations from this basic one, okay, that this plus 5 is just going to move this every point to the left 5 and then down 1. So my asymptote would move to the left 5, so it would be at negative 5. So where x equals negative 5 would be my asymptote. Okay, which tells me my domain is going to be negative 5 to probably positive infinity, because it's going to keep going to the right. Then that point up here that was 1, 0 will now be negative 4, 0. And then we go 3 from that and up to right about there, then to positive 5, 3, because that would be 9 minus. Anyway, something like that right there. So it looks something like this. Okay, so it's essentially going to have the same information as this one, just shifted to the left slightly. So like the range is going to be the same, negative infinity to positive infinity. The end behavior, as x approaches positive infinity, f of x is going to approach positive infinity because it will keep going up. Very slowly, but it will keep going up. Then as we go to the left, as x approaches negative infinity, it's going to hit that asymptote, so f of x is going to approach negative 5. Now, the weird one with 4 here, oh, and that should have shifted down slightly, 1. I was slightly off on that, but that's why I'd graph it with Desmos or with something so that you definitely have that correct. Okay, now this other one, we're going to drop it down to, and we're also going to invert it. So we'll have a vertical asymptote here at x equals 0. Okay, we shift everything down 2, we flip it. So this will actually shift up 2. My goodness. You get the idea. So it'll look like this actually. Okay, which is going to adjust some of our things. Our domain is going to stay the same, 0 to positive infinity. Our range will stay the same, negative infinity to positive infinity. Our end behavior will essentially stay the same as well. Okay, it'll be as x approaches positive infinity, f of x is equal to negative infinity because it's going down. And as x approaches negative infinity, f of x is going to be approaching 0. Okay, and there we go. Those are our logs. So the main point is being able to graph them and just talk about those different pieces. And there we go.